Today, you drive to a restaurant you have never been to before. You open the map on your phone, type in the name, and a little blue dot appears. You watch it move, turn, arrive, without hesitating for even a second. You do not know the road, but you know you will not get lost. Because above your head there are dozens of satellites, beneath your feet there are models of Earth's magnetic field, and in your hand there is a device thousands of times more precise than anything an ancient emperor could have used for navigation. You may even feel that the word lost has become outdated. As long as you have battery and signal, you always know where you are on this planet. But only 1,000 years ago, when the strongest navigators in the world left the coastline and entered the open ocean, their only navigation system might have been the shape of a cloud, the color of the water, or the angle of a bird's flight. If they judged wrong, they could die in a place so far away that even their bodies would never drift home. And for 2 million years before that, every human who moved, every person who left a familiar valley, faced the same deadly gamble. If I walk out, can I ever find my way back? So let's go back to the beginning. No maps, no road signs, no compass, not even language that could let you ask for directions. The only thing you had was your own memory. You remembered the shape of a twisted tree, the direction where the stream bent, the outline of a mountain, and how that mountain looked different from different angles. This was the earliest form of navigation, a chain of visual landmarks. Inside your brain, there is a region called the hippocampus, which helps build what scientists call a cognitive map. Researchers have found that London taxi drivers, who have to memorize around 25,000 streets, tend to have more gray matter in the rear part of the hippocampus than ordinary people. But that comes after years of training. Your ancestors 3 million years ago did not have a brain as developed as ours. They could probably remember the terrain only within a limited local range, maybe a few dozen kilometers around them. Beyond that was unknown land. And back then, the unknown was almost the same thing as death. Around 70,000 years ago, humans began to move out of Africa. They traveled thousands of miles, but they were not walking blindly. They used the sun and the stars. During the day, they knew the sun rose in the east and set in the west, and that at noon, in the northern hemisphere, it sat toward the southern part of the sky. At night, they knew the North Star stayed almost fixed in one place, and that the Southern Cross could point toward the south. But knowing direction was not enough. You also had to know distance, because you did not know how far you had to walk before reaching the next source of water. So people learned to count steps, to read changes in daylight, and to notice which side of a rock held more lichen, because the north side was often wetter, while the south side was often drier. All these details, stacked together, became the earliest rough version of latitude and longitude. But the people who truly turned navigation into something like a science were the Polynesians. Around 3,000 years ago, without modern instruments, they crossed the vast Pacific Ocean using only natural signals. They had a system called wayfinding. They memorized the pulse of currents and read the reflection patterns of waves because islands bend and scatter waves. Even when you cannot see an island, you may still be able to feel that something is there. They watched clouds. A tall island can push clouds upward, so from far away a stationary cloud might mean there is land beneath it. They turned the rising and setting positions of stars into songs and passed those songs from one generation to the next. A modern navigator once tried to sail from Hawaii to Tahiti this way. No GPS, no compass, and he succeeded. What guided him was observation, and a song taught to him by a Polynesian elder. Meanwhile, on land, we created something else: maps. The earliest maps were not drawn on paper. They were carved into stone, wood, or even bone. Around 14,000 years ago, in a cave in Spain, someone carved an abstract image that may have represented nearby hills and water sources. It might have been one of humanity's first travel maps. But maps had a major problem. Once you drew them, they were fixed, and the Earth was not flat. Not until the ancient Greeks realized the Earth was round, and even calculated its circumference, did the idea of location begin to become measurable. In the 3rd century BCE, Eratosthenes used the angles of shadows to estimate Earth's circumference at about 40,000 kilometers, with an error of less than 10%. At that moment, humans understood that latitude and longitude could be quantified. But quantification requires tools. The compass was invented in China during the Song dynasty. At first, it was used in practices like feng shui, and later it became a tool for navigation at sea. But a compass can only tell you north and south. It cannot tell you what latitude you are on. So Europeans developed the sextant, which allowed sailors to calculate latitude by measuring the angle between the sun and the horizon. With latitude, you could cross the Atlantic while following an invisible horizontal line across the planet. But longitude was harder. Longitude requires time because every degree of longitude corresponds to 4 minutes of time difference. At sea, clocks were easily thrown off by motion, humidity, and temperature. Then, in the 18th century, a clockmaker named John Harrison built a marine chronometer that could stay accurate for months at sea, drifting only by seconds. After that, for the first time, you could truly know which point on Earth you occupied. With latitude and longitude, maps became grids. But maps were still passive. They were records of roads other people had already taken. If you held a map, you could still go the wrong way, because the map did not automatically tell you where you were right now. So for a long time, navigation still depended on comparison. You looked at the mountains around you, then looked at the mountains on the map, and hoped they matched. If you could not recognize the match, you were in trouble. Then, in the 20th century, humans did something astonishing. We threw a collection of timekeeping stones into the sky. In 1957, the Soviet Union launched the first artificial satellite. American scientists soon realized that by studying the Doppler shift in satellite signals, they could work backward and estimate the position of a receiver on the ground. That was one of the foundations of GPS. In 1978, the first GPS satellite was launched. Today, more than 30 GPS satellites orbit roughly 20,000 kilometers above Earth. Each carries an atomic clock precise down to the nanosecond. Your phone receives signals from at least 4 satellites, calculates the differences in arrival time, and works out your latitude, longitude, altitude, and even your walking speed. The error can be within a few meters, and this system was originally built to help guide intercontinental missiles. Now it guides you to a milk tea shop. Every time you open navigation, your phone has to exchange a silent code with satellites in space. It has to download digital terrain models, call on cloud-based traffic data, and combine information from the accelerometer and gyroscope to judge whether you are walking or driving. All of this happens in milliseconds. Then a blue dot appears on your screen, and you follow it. You do not stop to wonder, why does it believe me? Because you do not know that thousands of years ago, if a Polynesian navigator could not see the stars, could not see birds, and could not read the clouds, he might simply stop the canoe and wait for days. Wait for the wind to change. Wait for the direction of the waves to give him an answer. Because moving blindly was more dangerous than staying still. Today, the moment your navigation says weak signal, you panic, you get annoyed. You wonder if your phone is broken. You treat not knowing where you are as a malfunction, not as the normal condition. But for humans, being lost was the normal condition. We spent millions of years making not being lost feel ordinary. You can walk through any strange city without fear, because you know there is a map in your pocket. You may even dare to hike in the mountains at night because your watch can send back your coordinates. You forget that your great-grandfather might have marked every fork in the road with broken branches. You forget that his father might have gone out fishing and found the way home by smelling the wind and watching the color of the water. We solved the problem of being lost so completely that we started to believe humans were naturally good at knowing direction. We are not. Humans may be among the easiest animals on Earth for the environment to swallow. We do not have the magnetic sensitivity of migratory birds, the polarized light vision of bees, or the electric field sense of sharks. By nature, we are terrible at finding our way. But we have something other animals do not have. We can put knowledge into tools. We carved the positions of stars into wood. We printed latitude and longitude onto paper. We digitized the entire Earth and placed it in our pockets. That blue dot is not just technology. It is a compressed coordinate package, paid for by the lives of our ancestors. So the next time you rely on that blue dot to reach your destination, you might ask yourself, if it disappeared right now, could you still get home? If your phone died, could you find your way back to your hotel in a strange city? How many stars could you recognize? Could you look at moss on tree bark and tell which way is south? Probably not. But that is all right because the blue dot is still there. And it is there because, once, there were people with no blue dot, no map, no compass, only a strange feeling that something might be waiting in that direction. And they walked. They made the first human paths. Those paths are now beneath your feet, covered by asphalt, covered by signal, crossed by you in a single minute, and you will never be lost again. That is wonderful. But maybe you will also never truly find anything again because everything has already been told to you in advance. Maybe this is civilization's most beautiful curse. We conquered distance, but we lost the terror and wonder of exploration.